Okay, so we did equations of planes the other way. You guys remember what the equation of a plane the other way was? So earlier today we did equations of planes. What was it?
X and Y equals Z.
It was f of x and y is
Z
2x
naught.
minus y plus 1.
not that one.
No, not that
Z
one.
But in general.
Okay, oh, that one.
Plus,
Z
Plus
naught
m
plus
of x, I guess.
okay,
or
right.
is S
The
of
slope
x
in the
or
x
the-
direction
Yeah.
times.
times
X
x minus x naught.
Oops, I'm writing kind of at an awkward angle.
Plus
Okay.
Plus
sy.
S of y. So then if you were to change it in a different way, then you could do like x naught plus s of y.
Okay, so this was our plane equation that we figured out based on the idea of what a plane was kind of doing, right? Like we figured this out by cross-sectioning a couple of different ways and thinking about what it means to be flat a little bit.
Yeah.
So this other way is going to be the vector way,
Oh.
okay? So we're going to start, here's a plane. That thing's not playing the role of a coordinate axis for now, it's just a toy I want in a second. So here's a point. I'm going to call that point P. There's another point over here. I'm going to call that point P naught. Okay. I'm going to give P naught some coordinates. That's just going to be like, I have a point and I want to talk about the plane that goes through it. So this point's going to be, what's your usual for random point?
A, B, C, or X naught or Y naught, Z naught.
ABC or X naught, Y naught, Z naught. I'm going to use X naught, Y naught, Z naught. Okay? Cool. Then I'm going to make a normal vector. Why would I make a normal vector?
So you can turn it into a unit vector. More
Kinda.
work.
How about this? Would a normal vector, right, if I told you which vector was perpendicular to this plane and that the plane went through that point P naught, would that uniquely determine a plane?
Yes.
You guys all kind of see that? Right? Because if I told you what direction sticks straight out, there's only one flat opposite that, right? Perpendicular to that. And then if I told you it goes through P naught, that locks everything in place, right? You see that? So this thing here is going to be my normal vector, right? So think about this as a normal vector sticking straight up out of my surface from my point P naught. Now, if we all buy this uniquely determines it, we should be able to, out of this information, be able to conjure our old formula, right? You guys see that? Okay, so can I get one of you guys to hold this thing? Okay. So what did we do yesterday with dot products? Uh-oh.
Said they weren't multiplication when they were.
Okay, good. They're not multiplication, but they act like it.
You can prove something's perpendicular.
Yeah, I can tell
Oh.
when something's perpendicular,
Or
right?
orthogonality.
Yeah, so here's my normal vector sticking straight out, right? If I dot product my normal vector with anything that sits in the plane, what would I get? Right? 0. So I know that I should be able to start with my normal vector dot with, I don't know, what do you call a vector in the plane?
X naught, Y naught, Z naught. Or X naught, X, Y, Z.
Okay, so here's my starting point in my plane, right? I need this vector to be in the plane, right? So I need it to be one of those based vectors. You guys see that? Or at least I need it to be a displacement vector.
Yeah.
So what's the vector that gets me from P naught to any point P in my plane? What if I give you some coordinates for P? Could you figure it out then?
Yeah.
Okay, so there's some coordinates for P.
So is it
P
x
minus P
minus?
naught.
Yeah.
Okay, cool. So this vector here then, right, is a vector made of
P minus P naught. But if x minus x naught, and then y minus y naught, and z minus z naught.
Okay. So I know if I take my normal vector and dot it with that thing, what should I get again? What?
Vector in your plane.
Yeah, that vector's in my plane. The normal vector sticks up perpendicular to it, so the dot product better be 0. That's really what we mean by perpendicular nowadays. And so I know that n dotted with this vector x minus x naught, y minus y naught, z minus z naught should be
0.
0. And wait, is that 0 as a vector or scalar?
Scalar.
Scalar?
A result.
The result of the dot product is
Perfect. Cool. Does that thing give you the same equation as this guy? Not immediately, at least, right?
Yeah.
So what would I need to do to establish whether or not that thing gives me this same equation?
solve
So
for
it's
z.
gonna be
Yeah, I'd need to do this dot product, right? And then try to solve for z.
We need the coordinates of the
Yeah, and to do that dot product, I need some coordinates for n. So, should we throw that up on the main board and get ourselves a result out of it? Okay. You guys are you all with me on the normal vector sticks straight out, and this displacement vector has to be in the plane? You're all cool with where those things came from? Yeah. Okay.